Camps on everyone. Let's start off. There, this was the last thing that we did. Been throwing the particles from a building horizontally at an angle and theta. Great. Let's see a question before going ahead. Particle is projected with 20 meters per second. This angle is 30 degrees. Height of the building is let's say 80 meters. So this particle flies, goes and lands on the ground. It hits the ground at an angle alpha. This is your range. Find range and alpha. Alpha is the angle made by the velocity vector when it hits the ground. There, let's get this. In root 3, I hope you guys didn't use u square sine 2 theta by g. That formula is not valid. You can't use a range ka formula u square sine 2 theta by g. That is valid only if you're throwing, coming back to the same level. 10 square root 3. Let's see, I don't remember the answer. I have to check. You got a minute, get them both.
Just send a message in the chat so I can.
You have to type in the chat box, right? Co-host. I think you sent it to the host. Let's see, I don't remember the answer. Even I need to do it. So what is the range? So what is your horizontal velocity? Ux is u cos 30, which is 10 root 3. Uy is u sine 30, which is 10. So whenever you want to find the range, you need to get the time of flight. So for time of flight, you always use the vertical direction. Sy is uyt plus half ay t square. So Sy is minus 80 meters. Remember, it's a vertical displacement. Uy is 10 into t. This is minus half. G is 10 t square. You get a quadratic. 10 goes off, multiply 2. So it will be t square minus 20t minus 16 is 0. This will be 20 plus minus root over b square 400. Numbers are bad, right? How much is that? 400 plus 64.
Quadratic, I think.
Quadratic I wrote wrong here.
Yes.
This is 2t, na?
Yes, it is like t square minus 2t.
2t tha wo. Yeah. That will be 2 plus root over b square is 4 plus 64 by 2. That will be 1 plus root 68. So that will be root 17. That's your time of flight. Okay? Then what is the range? Range is nothing but Sx. So range is nothing but Ux, time of flight, plus half Ax, time of flight square. But the horizontal acceleration is 0. So we'll not write this term. So be careful. Right now it is 0. Later on it will not be 0. The Ux is 10 root 3 into 1 plus root 17. That's your range. How do you find alpha? Uh, how do you find alpha? With what angle will it hit the ground? There are a few ways to do. One thing, you can use the tan alpha ka formula. That I don't like. There's a better formula. Think of it. How many formulas you have in terms of alpha? You have two formulas. Tan alpha is ui minus u sine theta minus gt by u cos theta. And second one, u cos theta is v cos alpha, isn't it? So this is what I can do. So when this guy is hitting the ground, let the speed be v. This is your state 1, this is your state 2. I can use conservation of energy. Energy in state 1 is equal to energy in state 2. So initial energy half m u square plus height is mgh is equal to half mv square. M cancels, this will be half u square, this will be 400. G is 10, this is 80 is equal to half v square, that is 200, and that's 800, so that is 1000. So v is equal to 10 root 10 meters per second. Clear with that? So this is the speed you hit the ground, and then I can use u cos theta is equal to v cos alpha. U cos theta is 20, cos 30, which is root 3 by 2. V is 10 root 10, and that is cos alpha. 2s are 20, 10 it is gone, so cos alpha will be root over 3 by 10. Yeah, you can convert this into tan also. It works out. This would be a faster way of doing it. Because if I want to use a tan alpha ka formula, the problem is this: u sine theta minus gt. I need to find the time of flight, na? So it involves two steps. First, find the time of flight using this quadratic, and then substitute in the formula, and then solve. Yeah, it is lengthy. But yeah, here also it is there, but yeah, you won't deal with the quadratic. You can use conservation of energy. Clear with this? Any doubts on this? Next one. Next one. We got a building here. You projected a particle with speed u, 20 meters per second, at an angle of 60 degrees. This particle went straight up, and then it fell on the building at an angle of 30 degrees. H is the height of the building. Find H.
Then in the last question, my V comes out to be 20 root 5.
20 root 5.
Yes. The half of the V square.
And this is 1000. This is 1000, no? That is 2000, right?
Yes.
Yeah, it's a mistake. Kitna tha then?
20 root
Two-
5.
2020 root 5. Sahi tha. I goofed up there. This is 20 root 5. How much is that? Root 3 by 2 root 5. ठीक है. You're right. Calculation mistake. Get this thing. So you projected a particle at 20 meters per second. It goes and falls on a building at an angle 30 degrees. Find the height of the building. How do we do this? Generally, this is a hint. Whenever they talk about initial and final speeds, kind of, see, if your speed is v here, do I have a relation between them? I know u cos theta is v cos alpha. Anytime you see a final angle, they're talking about alpha. The u cos theta, this will be 20. This is half. This is v, and this is root 3 by 2. So from here, I get speed v is equal to 20 by root 3. Means you're going and falling on the building with this speed. Then state 1, state 2. You can conserve energy. So this will be half mu square. Now, remember, height is on the other side. So the final, you have a potential energy and half mv square. The m goes off. This is u square by 2. That's 400 by 2. This is g. H ka value I don't know. This is half, and this is 400 by 3. 200. This is 10h, and this is 200 by 3. 1 0 goes off. We get h is equal to 20 minus 20 by 3. 40 by 3 meters. Yeah. Clear this? So there. So just because it is a kinematics question, don't think in kinematics. So we used a part of kinematics, then we used a little energy conservation. Saves you time. You can do it using pure kinematics also. It goes a little lengthy, but it can be done. So generally, whenever you have final speed or whenever you have final angle, think about that. Energy is always an option. Clear with this? Not a tough question. Would have taken maybe 2-3 minutes, but it does. You can handle this in 2-3 minutes. Next one. Any doubts on this? All got this. Advait, Advait, clear with this? Shreyan, Tanishka, Utsa, got this? Next one. So we have a particle projected with u at an angle theta. So for the first half of the range at r by 2, so r is your u square sine 2 theta by g. So till this first half of the boundary, the gravity is g. Once you cross this boundary, the gravity becomes 2g. It's a weird planet. So this particle will fly like this, and then it will become something of this sort. It won't go in your regular projectile motion anymore. And let's say it falls somewhere here. So it falls x on the other side of the boundary. Find x. The particle is projected with u at an angle theta. after reaching H max, the gravity becomes 2g. So once you cross that, so r by 2 is your H max point. Try and actually, Harry. Try and tell me what you will get. You have an idea, you should try. Give it a try. You got 3 minutes. The left half of the boundary, the gravity was g. The right half of the boundary, gravity is 2g. Then what is x? Exam options will be in terms of r. Like r by 2, r by root 3, r by root 5, ऐसा options होगा. So give me answer in terms of r. Where r is your regular range. Nee, Arya, wrong. Nee, Param, wrong. It's not r by 4. I know what you guys are doing. You just made g ka place mein 2g and you got half of it. It doesn't work like that. This range ka formula was derived under the assumption the whole gravity was g. Try. मैं right हो गया. 2 root 2 ना? Yeah, you're right. You have one answer. Right, Shriyansh. You have all the data here. So when you project it with u and theta, when it reaches h max, the speed will be u cos theta. So the right side of the gravity became 2g. So the question has become like this, and this height is h max. So can I say the whole question has become like this? So the new question is, we have a building of height h max. Someone throwed a particle horizontally with a speed u cos theta, and here the gravity is 2g. And I'm asking you to find the range. Are you getting how I can reframe the question? Can I say like this? So I can reframe the question like this. A particle is thrown with u cos theta from a building of height h max where the gravity became 2g. What is the time of flight when you throw it horizontally? Root over 2 times h by g. G ka place mein you will get 2g. Agreed? Whenever you throw horizontally, the time of flight is root 2h by g. G ka place mein you got 2g. Right? And then what is the range? So x is equal to horizontal velocity ux into time of flight, which is u cos theta, and the time of flight is root h by g. What is h? U square sine square theta by 2g square. So that thing comes out. You'll get u square sine theta cos theta by root 2g. Multiply and divide by 2. That will become 2 sine theta cos theta. It will become sine 2 theta. It will become u square sine 2 theta by 2 root 2g, which is nothing but r root 2. Is that clear, everyone? So that's how you convert the problem. You can't use the equations for the full motion. So what you do, split the motion into 2 pieces, isn't it? So do it for the first half and then do it for the second half. The second half problem will look like you're throwing from a building of h max with speed u cos theta. Gravity is 2g. That you know how to do. All got this? Any doubts on this? Any step you're not convinced, please ask. Clear, na, Tanishka? Sudiksha, clear with this? Ishman? Aditi? Similar thing, what if you project it with u and theta, when it reaches this h max r by 2, the gravity is g this way and the gravity becomes horizontal. Find time of flight. This is another weird planet. After reaching h max, the gravity, so after the boundary rate, after r by 2, the gravity is horizontal. So can you draw the path and find the time of flight?
So there is no vertical gravity there.
I showed now. Here horizontal vertical gravity, here horizontal gravity.
Okay.
The left half gravity is down, on the right side gravity is horizontal. It's a weird one, weird planet. If you throw a particle like this, what is the time of flight? Draw the path and get the time of flight. Think, you got 2 minutes.
So like, does the gravity become horizontal on the whole planet or just on the right side of H max?
On the right side. Right, Samir, we have one answer. So on the right side of the boundary, it is G horizontal. On the left side of the boundary, it is vertically G. You're missing a tour area. Let's see how will the path look like. See. So initially when you projected this, so this will go till here. That will be the h max. At this point, the velocity is u cos theta. Agreed? And now the gravity became g this way. So if you can just rotate your book 90 degrees, if you just rotate it 90 degrees, doesn't this look like a vertical projectile? Can you see that? Doesn't that part look like someone projected a particle up with u cos theta and the gravity is, it'll just go up and down, na? So once you cross the boundary, the motion becomes a straight line. So at this point, it'll just go in a straight line. It'll stop somewhere here. It will come back again in the same direction. And once it comes back, again, it'll come back with u cos theta. Then again, it will retrace the path and again come back to the same point of projection. Can you see the path, everyone? At h max, the velocity and the gravity are opposite to each other. So it will just take a U-turn. It will go straight for some distance. It will take a turn, come back, and then come back to the point of projection. Is that making sense? So you can split the whole motion into 4 parts. So this is one part. This is one part. Then you'll come back again. And then you land again like this. So what is this thing? This is the time of ascent, u sine theta by g. This will be u sine theta by g. This green one, to go and come back, this will be 2u cos theta by g. That is just like your regular vertical projection. The total time of flight will be 2u by g sine theta plus cos theta. Easy? So once you cross the boundary, it becomes a 1D motion. It just goes in a straight line and comes back. And it will retrace the path. Any doubts on this?
So it will be stuck in the air for the other half.
No, na. Here, air matlab, yeah, it will just go and come back, na.
Oh, so it
It will come back, right? The gravity will pull you back, isn't it? You will go opposite to gravity, you'll slow down, you'll stop, and then you'll come back. Once you come back and cross the boundary, again gravity became down. Then again you'll go back.
Yeah, so it's like a planet has appeared on the bottom, other half.
Yeah, kind of, yeah. Clear with this, Advay? Got something?
Sir,
Yeah.
so once the gravity acting horizontally acted, it could also land upon some point between R2 and theta 2, right?
But look at the velocity, na God. Velocity u cos theta is this way, gravity, both are opposite. It's not a projectile motion. It's a 1D motion. If velocity and acceleration are opposite, how will it travel? It will travel in a straight line.
Yeah.
So it won't land anywhere else. It has to go and come back. If there is a gravity vertically, then it will land. Clear with this? Now, same thing, I can modify it a bit. Tell me how will this look? Okay, we'll not solve this, but let's say same question. This boundary is r by 3. This gravity is g and this gravity is g. And you projected with u and theta. Can you draw the trajectory? How will the path of this particle look like? Similarly, let's say this boundary is 2r by 3. This gravity is g, and let's say this gravity is g this way. So previous question I gave r by 2, so it became pretty nice. But what if the boundary is not exactly at the center, but somewhat like this? Can you draw the trajectories? How will this particle travel? Roughly. Give it a try, I'll give you a minute. I can always ask a question. Find you if it comes back to the initial position. It will be a deadly one, but let's see. Just get the trajectory. Now, this won't be like the previous one. The previous one is pretty nice. Like a wave, yeah. Just draw, I'll show you, then you can see whether you got it or not. I know you won't be able to type this. The first case r by 3 matlab you still didn't reach h max. So look at the first one. So when you're going like this, at this position, you still have a horizontal velocity ux and vy is vertical. Now suddenly the gravity became horizontal like this. So for this particle, the motion will look like this. It's a projectile motion like this. It will go like this. And once it comes out here, to draw it a little down. Once it comes out here, again, it will come back with the same velocity Vx this way and Vy will be this way. So now it is going this way and gravity has become again G here. So this will fly like this and will land somewhere here. You're getting the motion? It would look something like this.
So won't it land on the same point again? Because
There's no guarantee, na?
complementary angles.
There is no guarantee. This height is become like a building, na? No.
Oh, right. Huh.
When you come from the left-hand side, this became like a building of this height now. And there's no guarantee it will land. It can land, so that would be a question. Find u if the particle lands at the same place. But you're getting the trajectory? इसका क्या होगा B का trajectory? Assume there is no ground, okay? Assume there is no ground. Then how will B ka trajectory look like? That would be the shape of the path. So here 2r/3 meaning you already crossed h max and you're coming down. So this is Vx and this is Vy. So it will go like this. It will go like this, assuming if there is no ground. It will go like this. It will cross this boundary. Then the gravity will pull you down. So this is how the path will look. Clear with this? They'll be pretty weird. Like I said, this thing is pretty nice. This can be messy. Any doubts on this? There. Let's see one more. We have projected a particle with u and theta. This point is at x is equal to 0. Again, we have a weird planet whose gravity g is changing as g naught x. The gravity is not constant. G naught is constant. It's changing with x. This x is your x coordinate. G naught is some constant. Find h max, time of flight, and range. And just to give you a brief, look at this gravity, how it is. Initially, when x is 0, what is the gravity? 0. As x is increasing, gravity will increase, gravity will increase, gravity will increase, gravity will increase. The more you travel forward, the gravity is becoming more and more and more. You're getting this thing. The more you travel forward, it is changing with x coordinate. The gravity is becoming higher and higher as you go more and more into the front. So the gravity is not changing with height, it is changing with x coordinate. Hope the question was clear. This would be a pretty good one. This would be an advanced question. Let's give it a try. So again, we are doing some weird planets. So this is a last weird planet. And we can create more, but I think this should take care of all the weird planets. Let's get this. We got a place where the gravity is increasing with x coordinate. Think for 3 minutes. Then I'll give you some hints and then we'll see. This is going to be a good advanced paragraph at your level. If it's an advanced question, it could be they just ask you range as a single choice question or an integer. How do we approach? I'll tell you what people generally do. Tell me, what do you think about this? So acceleration is g naught x. So I can write this thing as v dv by dx. What do you guys think about this? What do you guys think about this equation? This is a blunder. That's a blunder. Now tell me why it is a blunder. Obvia, got something?
Is it because we're like trying to say that your dv by dx, it should be like dv by dy, like in the y direction?
Because the acceleration is in y direction. So here, if you see, the acceleration which you got here is ay. So this ay is minus g naught x. So when you write this, this should be vy dvy by dy. You're getting it? This is right. You can't write this as v dv by dx. You're getting the difference? So this is the right thing. So you can't write like this. So don't write a is equal to minus g naught x and don't say this is v dv by dx. This is wrong. This is great, but what is the problem? I don't know how to integrate this. There is a vy, there is a x, there is everything is there. We can't integrate this directly. So we are stuck actually. I mean, in this entire question, right? There is something constant. What is that?
Horizontal velocity.
Horizontal velocity. If you see here, there is no horizontal acceleration. Since there is no horizontal acceleration, the horizontal velocity will remain constant. That is, ax is still 0. This is still ay. Therefore, your x is equal to, so horizontal velocity is constant. Therefore, your ux is constant. That means I can find my x coordinate. So your x coordinate is u cos theta t. This is still valid. Now what? Now try. I'll give another 2 minutes. Like this is what I was saying. When you're actually solving a question, this is what you're supposed to do. This is how you think. When I tell you, try a question for 8 to 10 minutes, try to think about all possibilities. This is what I mean. I'm never saying finish all the question. Where did we solve the question? We didn't even solve. Last 3 minutes, I'm just discussing what all things can happen. What are constant? What are variables? What mistakes can I do? This is what you mean by thinking. When you learn like this, when you even study like this, your subject will really reach, very good level. When you see a question, you can analyze in every format. But if you're just running behind an answer, temporarily it will be fine. But after 3-4 months, you will start having real problems because the questions will be so tough, you will not be able to understand how to think only. Now what? Think. You got 2 minutes. So in the class, every time I give you that 1 or 2 minutes, it is for you to think. It is not to get an answer. There we figured out the horizontal velocity is constant. If the horizontal velocity is constant, I got the x coordinate. And there is one more place where there is an x coordinate, which I marked with the blue circle, blue egg actually, blue ellipse. Now what? Try. 2 minutes and I'll show you. Root. Why are you finding root ray? What is that? Is that H max or range or time of flight? What did you even find? G naught is not 10 ray. G naught is not 10. G naught is a constant. Hope you didn't take it as 10. तो वही किया. I understood. Listen. So it is given ay is minus g naught x. But x we just now found out. This is nothing but u cos theta into t. What is ay? Dvy by dt. Since the acceleration is in the vertical direction, velocity also must be in the vertical direction. This is minus g naught u cos theta into t. Integrate this on both sides. Dvy is equal to minus g naught. You can't use your regular equations because acceleration is changing. Integral t dt. When time is 0, your velocity is u sine theta. Remember, this is the initial vertical velocity. This is t and this is vy. This will be vy minus u sine theta is equal to minus g naught u cos theta t square by 2. This will give you velocity in the vertical direction. This might look a little weird and tough, but you have done this before. You have done this, where in kinematic calculus. This is the question, 8th one, a is equal to t. Similar integration we have done. Only thing, there are some constants, u sine theta, u cos theta and all that, but it is the same integration. This is your velocity with height. Let's see, what is the answer? Could be right. Then, still not over. What is Vy? Vy is dy by dt. This will give you your y coordinate. This will be u sine theta minus g naught u cos theta t square by 2. Integrate on both sides. This will be dy. Limits will go from 0 to y. U sine theta dt. Limits will go from 0 to t. Minus g naught u cos theta by 2 integral t square dt. 0 to t. So this will give you y is equal to u sine theta t minus g naught u cos theta t cube by 6. This is your y coordinate as function of time t. I actually know everything. I know x coordinate, which is u cos theta t. I know the y coordinate. I know vy. I know vx. I got all the positions. I got all the velocities at any time. Still, the question is not over. Can you find h max, range, and time of flight? Now what to do? I'll give you a minute. 2√2 time of flight near हो गया. कुछ तो गड़बड़ था. 2√2 नहीं आएगा. root 2. How are you guys getting time of flight root 2?
Can you check
Till here,
my
any doubts in
answer?
the steps? No, not right, Arya. That is wrong. So Diksha, let's focus on the class. How do we do this? Now what? I got the x coordinate, I got the y coordinate, I got vy, I got vx. I literally found all the velocities and all the coordinates. So ask yourself, what is time of flight? What is time of flight? The time when you reach the ground. हाँ भैया बोलो ना.
From the like equation you got like Vy equals to that.
Hmm.
That also we're like getting the time of flight as
Nah,
ascent as we get time
you
of
got time of ascent.
and then we multiply by 2, right?
Who told you time of ascent is equal to time of descent? Is the gravity same? But logically search, while you're flying, gravity is less. While coming down, the gravity has increased even more, isn't it? You can't double it. Time of ascent is not equal to time of descent, everyone. I'll show you that also. Time of descent क्या होगा? हाँ, Aditi, clear with this? Any doubts on this part, please ask me. It's a double integration to get your y and vy. Question is still not over. How do you find range from here? Tell me one thing. When you say range, so this particle here will go here, will fly, it will go in some weird path, it will not be parabola, it will land somewhere here. So when it lands on the ground, what is the y coordinate? 0, right? That means when y coordinate is 0, the time will be the time of flight. So the time of flight, the y coordinate must be 0 because you came back to the ground. And what is y coordinate? This guy. So y is nothing but u sine theta t minus g naught u cos theta t cube by 6. And when you equate this to 0, you'll end up with time of flight. T will be, and just put time of flight here. So TF is 0, that is the initial position. You'll get time of flight is equal to 6 tan theta by g naught. Root. This is your time of flight, everyone. Right, Utsa. Right, friends. And what is range? Range is simply horizontal velocity into time of flight because there is no horizontal acceleration. So this will be u cos theta into root over 6 tan theta by g naught. Done. There we got the range and the time of flight. Question abhi tak hua nahi. We have to find h max. How will you find h max? Any doubts on this part? Tell me one thing. At h max, what is 0? At h
Vy.
max, Vy is 0.
Y component, yeah.
Y component, right? You have only the horizontal velocity, u cos theta. That means make Vy 0. This equation, if you put it 0, I'll get time of ascent. So the thing is still the same. The way we derived the time of flight in h max, the idea is still the same. The equations are different though. So for h max, or you can say for time of ascent, Vy is 0. So Vy will be u sine theta minus g naught u cos theta time of ascent square by 2 equal to 0. So from here we will get time of ascent will be root over 2 tan theta by g naught. So what will be the time of descent? Time of descent is nothing but time of flight minus time of ascent. That will be root over root 6 minus root 2 root tan theta by g naught. There, they are not equal. Clear with this? That itself is another question. Find time of descent. You can't just double the time of ascent here. Is this clear, everyone? Abhi tak question hua nahi. We didn't find h max still. We found time of ascent. So if you take time of ascent and put it in the y coordinate, you'll get time of h max, isn't it? So for h max, t is equal to time of ascent, which is 2 tan theta by g naught. Put it in the y coordinate. What's the y coordinate here? U sine theta, time of ascent. This is your h max. This is a lengthy one. It's a good one. You cos theta by 6 time of ascent ka cube. Substitute here, solve this. This will be u sine theta 2 tan theta by g naught. I think you can just take out one TA common. This will be u sine theta minus g naught u cos theta by 6, and this will be 2 tan theta by g naught. G naught will cancel. Tan theta will be sine theta by cos theta. Cos will cancel. That will be 3. You end up with 2u by 3 sine theta root over 2 tan theta by g naught. There. That's your h max, everyone. But all this starts with finding Vy, Vx. These are the two things. If you don't know the y coordinate and the Vy, you can't do anything. Is the integration clear? Once you got the integration y coordinate and Vy, for time of flight, put y is 0, you'll get time of flight. Range will be ux into time of flight, you'll get the range. Put Vy 0, you'll get time of ascent. Take the time of ascent and put it in the y coordinate, that will give you h max. Check it out. This is a question which is difficult to solve also, it is lengthy also. There are steps, too many steps. It's a good one, but this is the kind of questions you can expect in advance. Any doubts on this? Next one. There, that is a little about the weird planets. So gravity became g and 2g, gravity became horizontal, the gravity is changing continuously with x. You can keep playing it, but I think you got an idea about how to handle these things. Next one. Let's see something little easy. We got a tall building. You projected particle A horizontally with speed u. So this thing goes off like this. You projected particle B also horizontally with 2u. It goes off like this. So you're projecting A and B horizontally, gravity is there. With u and 2u horizontally from a building as shown. Find the time when, first question, velocities are perpendicular. So velocity of A must become perpendicular to velocity of B. Second question, when displacements are perpendicular. So displacement of A must become perpendicular to displacement of B. There, two questions. So both the particles are projected opposite to each other. So as they're flying, at some point the velocities become perpendicular. At some point the displacements become perpendicular. Find the time.
So do we have to consider the downward direction as negative?
Yeah, positive, down, negative. Keep the convention simple. Root 2 u by g. Yeah, that looks right. U by g root 2. Samya, right. Right, are you? Param, not well. You're not keeping well.
I'm fine, sir. Just a little tired.
Chalo, try others. Meaning, in case, what was the question? Meaning, if I have to show the diagram, see, this is how the diagram will look like. So when you projected this from a building, so when A is projected here, this velocity goes like this. When B is projected here, this will go like this. So what I'm asking is, at some time, this velocity will be VB. If you extend the vector, at some time, this velocity will be VA. When you extend this vector, this is 90 degrees. That's your first question. The two velocity vectors have become perpendicular. What is the velocity vector for VA? VA bar will be, remember the formula? U cos theta I cap plus U sin theta minus GT J cap. And here theta is 0. So this will be simply U I cap minus GT J cap. For VB, be careful, you're projecting it backward. So I cap will be a -1. So VB will be minus 2U I cap. So theta is 180 basically. Plus, and this thing will be, for this guy, theta is 180. And this will be minus GT J cap. And if two vectors are perpendicular, then the dot product is 0. VA bar dot VB bar is 0. How much is this? Minus 2U square plus G square T square is 0. So therefore we get time T is equal to root 2 U by G. Make sense? That is the first part. What is the second part? The displacements are 0. So when you throw the particle A from here, when it goes like this, when you throw B here and when it goes like this, so now after some time, let's say A is here, this will be the displacement vector SA. When B is here, this is the displacement vector SB. And now you are saying when you extend this, this is 90 degrees. Are you getting the difference between both of them? Yeah.
Sir, after you solve, I have a doubt.
बोलो ना क्या doubt था?
Sir,
This is
while
the
I
doubt.
was solving, I got t square is equals to 0 when I cancelled out the t square term.
Yeah, so T0 meaning initially, right? Both are 0 vectors. So 0 vectors can have any direction, so they can be perpendicular.
Oh, right. Okay.
So you got actually one answer as T is 0. That means the initial condition, right? Initially displacement ही नहीं दोनों का. So that way, that is the meaning of it. Then what is the displacement of SA? Remember the formula? U cos theta T I cap plus U sin theta T minus half GT square J cap. There, I am not using anything new. We have derived all this stuff. These formulas are still valid even if you throw from a building. So this guy with theta will be 0. And this guy theta will be 180. So basically you're throwing it backward. So SA will be U I cap, U T I cap. Theta is 0, so sin theta is gone. Minus half GT is J square square. You need not even write that formula. You can actually see and say, horizontal velocity is there, vertically it is half GT square. So this guy will be minus 2 UTI cap minus half GT square J cap. They're perpendicular, the dot product must be 0. SA dot SB is 0. How much is that? Minus 2U square T square, 1 by 4 G square T cube. I think we'll get time is equal to 2 root 2 U by G. Check. Have a look at the steps. Projectile motion, vectors, dot product.
Sir, if it were for both of the projectiles to be projected with u horizontally, then would we obtain a time when their velocity and their displacements are perpendicular?
You're saying both are throwing with U and U.
Yes.
करो आएगा ना क्या आएगा आंसर if you do U and U you will get U by G, right? ये 2 नहीं आएगा बस you will get U by G. What is the difference?
So their velocities are perpendicular when they are at the ground.
Who told you U by G is the ground ka time?
So because it's time of descent, right? Oh no,
I'll
but we
punch
cannot
you.
say
This you're
anything
throwing
about.
from
Yeah, we cannot say anything, right? Just
हाँ,
that
build time of flight
straight
कितना
from
था? 2h/g था वो, h दिया नहीं मैंने.
yeah.
हाँ, u/g time of descent. Don't remember like that. Clear with this? Take a break. Come back by 9:38. We'll continue from here. Any doubts so far? Chalo, come back in 5 minutes. Let's see. Next one. Now, this is a good one. You have to remember the standard result. So let's say particle is projected with u and theta. So find the condition if the particle is always going away from the point of projection. What do you mean by that? The meaning of this thing is the distance from the point of projection must always increase. I'll show you some examples, what it means. So distance between particle point of projection is always increasing. Meaning, see, suppose if I throw a particle like this, see what happens to the distance. So initially it is increasing, 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 then it starts decreasing, right? Can you see the length of the vector is again decreasing? So I want you to throw at such an angle. So I want you to find theta such that when I throw this particle, this vector r bar should be always increasing. You're getting it? That length, the distance from the point of projection should never decrease. It should always keep increasing. So if you throw it vertically, this will increase, increase, and then it will decrease. So I don't want this to happen. Is that making sense? So basically condition is find angle basically. Find theta. Find the condition that is theta if the particle is always going away from the point of projection. Get me the angle, Nare Arya, and keep your cam on. How will you approach this? For example, see if you throw something like this, if you look at the distance here, so here see r bar decreases. While coming down. This should not happen. So how, with what angle should I project so that that distance or this mod r bar always increases? This is a result you should definitely remember. Exam may, it will be a little lengthy to solve, but try, think for 2-3 minutes, then I'll show you. But what is alpha? Alpha is changing every instant, na, Aditi? So you need to give me a certain initial value, isn't it? Let me tell you something. See, listen, then I'll give you some time to solve. So when you're projecting this particle with event theta, at any instant, look at this thing. So at some point here, let's say if this is your R bar. At this instant, this is your V bar. And let the angle between them be alpha. If R bar and V bar, right, if the angle is acute, if R bar is always increasing, that means there should be a component of velocity along R bar, isn't it? If R bar is always increasing, then the angle alpha must be always acute. Do you guys agree with that? Think about this. If V is this and R bar is this, then if this angle is alpha, then this component V cos alpha will increase the R bar. But let's say R bar and V bar, the angle is obtuse, then this component will be V cos alpha. This will decrease R bar. Is that making sense? If the angle between V bar and R bar is alpha is acute, then the angle will always increase. So that is R bar dot V bar must be greater than 0. Make sense? If the angle is acute, then R bar dot V bar must be greater than 0 because cos alpha will be. So this will be mod R bar, mod V bar. This is cos alpha. So if alpha is acute, then cos alpha will be positive. If alpha is obtuse, it will be negative. This must be greater than 0. There. So indirectly, the dot product must be greater than 0 if R bar is increasing. Is that making sense, everyone? So think of like this. I will show you. Say, let's say if this is your R bar, this is your V bar, and this is alpha. So this components will be V cos alpha and V sin alpha. So here V cos alpha increases R bar. Instead of this way, let's say the angle is obtuse. Then your component will be this way, which is V cos alpha. Right now here V cos alpha decreases R bar. That way. So this is acute. There, this is your condition. R bar dot V bar is greater than 0. You know R bar, you know V bar. Can you do it? In a projectile motion, you know how to find R bar, you know how to find V bar. Can you do the dot product of that and see what you're getting? Now try. I'll give another minute or two.
So can we solve this using d mod r by dt?
वो भी कर सकते हो, वो भी सही है. Or you can also argue with the statement that d mod r by dt is greater than 0. That is also true. This is an alternate. But वही आएगा, same thing. That thing is little differential and all, yeah. Since mod r bar is always increasing, the change in r bar should be always positive. Yeah, you can do that also. You can take a mod r bar and differentiate and say always greater than 0. Works. How do you do this thing? See. So we got r bar dot b bar is greater than 0. R bar is what? U cos theta t I cap. Q sin theta t minus half gt square j cap. dot product, velocity will be u cos theta I cap, u sin theta minus gt j cap. This is greater than 0. So if you do the dot product, this will be u square cos square theta t plus this will be u square sin square theta t minus u sin theta g t square minus half g t square u cos theta. I just multiplied this and these two. Then I'm multiplying this with these two. Half gt square u sin theta plus half gt cube. This is greater than 0. Take out t common. You'll get u square cos square theta, u square sin square theta becomes 1. That becomes u square. This is u sin theta gt square. This is half gt square u sin theta. That becomes minus 3 by 2. And that will be half gt square is greater than 0. So we got a quadratic equation here. Half gt square minus 3 by 2 u sin theta gt plus u square is greater than 0. Now tell me one thing. If a quadratic equation is greater than 0 means what? It is not equal to 0. That means this function has no roots, right? If a quadratic is greater than 0, that means this function has no real roots.
Why, sir?
What why, sir? The function is not equal to 0. You guys didn't learn this in max. Didn't do again max my wavy curve and all that stuff. If a parabola crosses this, these are the two roots, right? The point where it crosses the x-axis are the roots. Y coordinate is 0. If y is not 0, matlab kya? Your graph is like this. It is not crossing only. There are no real roots. When you say y is equal to ax square plus bx plus c is equal to 0 and get the roots, what do you mean? When y coordinate is 0. If y coordinate is not 0, then you'll not get any x coordinate, right? Clear with that, everyone? If a quadratic is equal to 0, means you're saying the function becomes 0 for a particular time. If it is not 0, it doesn't become 0 at any time. So this has no real roots. Therefore, the delta discriminant must be less than 0. B square minus 4ac is less than 0. You're done. So what is the discriminant for this guy? The discriminant for this thing, b square, is 9 by 4 u square sine square theta g square minus 4 g by 2 u square must be less than 0. U square goes off. I got a g extra somewhere. For AC na.
Sir, in the second equation, it should be, I guess, g square t cube.
G square
Last term.
sine. Yeah, this one.
Yes, sir.
वो g square था. सही था. G square. So u square goes off, g square goes off. You're stuck with 9 by 4. Sine square theta minus 4 is less than 0. That will be 2 there actually. So we get sine square theta is less than 8 by 9. Sine theta is less than root over 8 by 9. That's your result, everyone. Definitely mug it up. Exam, you won't have time to derive this. That means whenever you throw a particle with an angle less than sine inverse 8 by 9, R bar will always increase. Any angle greater than this, R bar will decrease. Again, what did we do? So first thing is to figure out that R bar and B bar will make an acute angle. Because if the angle is obtuse, then the R bar will start decreasing. So R bar dot V bar is 0, then we got a quadratic. Since the roots are greater than 0, means this function has no real roots. Discriminant delta is less than 0. This is more of a max problem than physics. I think the only part where you used physics, right? This dot product is actually max. Yeah, there's a physics there, but this is more of a max problem. There's too much max. Check it out. This would be a standard result. You should remember this thing. It will just suddenly pop up in some exam. You won't have time to do all this. If you know the result, you're done, or else you're stuck. And it happens. They do have a habit of asking like this in exams. I still remember when I wrote my CET exam, I got 8 questions from Erido in CET. Literally, they took the questions and dumped it in the CET exam. One thing, everyone got slaughtered. That's a different story. That is one thing. Paper becomes tough. Everyone struggles. Unfortunately, the thing is, I don't remember the answers. I didn't have time to solve the paper. But overall cutoff also came down. CET, my paper, right? It used to be like this: 80 marks, mathematics, 40 physics, 40 chemistry. I think in physics I scored 31 or something. I couldn't do those Irido ones. I didn't have time. And I think max I got some 71 something. Chemistry I got something, and that still gave a rank of 600. So it is fine. If the paper is tough, that is tough for everyone. Clear with this? Yeah, today was CET results for your seniors. Most people did really well. 99.7s, 99.8s. Any doubts on this? Next one. Definitely go through the today class notes. We really have some tough ones that we did. This entire projectile is like this only. You can see what we are doing. We are just combining everything: vectors, calculus, projectile, 1D, 2D, everything keeps on coming. Let's do something a little more easy. So we got a ground here, cricket ground. You must have seen steps look like this. So someone throws a ball with a speed of 20 meters per second at an angle of 60 degrees. This distance is 20 meters. Here, each step is 1 meter wide and 1 meter high. So each step is 1 meter high and 1 meter wide. So this ball goes here and falls on some step here. So find the number of the step where it falls, like first step, second step, third step, fourth step, and so on. Just get me the equation. No need to simplify. If I give you good numbers, you can solve, but I don't think numbers are good. So find the number of the step where it falls. Question is clear? Remember, you can't use a range ka formula. It is not coming to the same level. Get this. So the steps start at a distance of 20 meters. When you hit this ball, this will go and fall on some step. On which step does the ball fall? Just get me the equation. Sufficient. many steps. Yeah, right, Srihari. वही करना था और कुछ नहीं है. See, this thing I told you. Remember that problem where the stone went into the window? Doesn't this look like that? बस window यही पे था. So let the stone fall on a nth step. So then this coordinate will be, if it goes and falls on the nth step, means it will travel horizontally 10 meters and it must have gone to a height of n. So this coordinate will be 20 plus n, comma n. So indirectly, didn't I give you x and y coordinates? I gave you x and y coordinates. I gave you u. I gave you theta. Which equation fits all this data? Equation of trajectory. Y is equal to x tan theta. You can use x is u cos theta t, y is u sin theta t, but you'll get the equation of trajectory only. Gx square by u square cos square theta. Gx square 2u square cos square theta. There, you know everything. So y coordinate is n, x coordinate is 20 plus n. Numbers are bad. Tan 60 is root 3 minus g 10. X square is 20 plus n whole square by 2. U square is 400 and cos square theta is 1 by 4. Yeah, you can simplify this. You'll get n ka answer. Leave it here. You're getting range 20 root 3. 20 by under root 3 you're getting range. Maybe I took the values wrong then. Okay, I can just increase the speed. Big deal. Clear with this? So remember this thing, whenever they ask you a question like this, it goes and falls at some place. What is that position? The moment you talk about the final position, he is giving you the final x and y coordinates. It is mostly equation of trajectory. The stone problem which was thrown into the window, this one, all these are based on same category. Let's see one more. Any doubts on this? Let's say we have a building here. We have one more building here. So there is a window here at a depth of 20 meters from the top. The distance between the buildings is also 20 meters. Someone projected a stone with speed 20 meters per second. So this stone went inside and fell into the window at an angle theta. Find theta. All are 20. Speed is 20. Distance between the buildings is 20. The height of the window from the top is 20. Find theta if the particle goes into the window. Yeah, this you'll get good numbers. Solve this. Let's get this. Root 8. Nay, that won't be the answer. I clearly gave you the window coordinates. Remember, the point of projection is always the origin. So this point of projection, let this be origin 0, 0. Then this window will be 20, minus 20. Agreed? It's going down, so y coordinate will be negative. You're done. Equation of trajectory satisfies this thing. So y is equal to x tan theta minus gx square by 2u square cos square theta. Y is minus 20, x is 20, tan theta 10, x is 20 square, 2, u is 20 square, cos square theta will go up, it will become secant square theta. 20 square goes off, you get minus 4. This will be 4 tan theta. The 2 and 10 will become 5, 5 will cancel with this. And secant square theta is 1 plus tan square theta. You get a quadratic in tan. So this will be tan square theta minus 4 tan theta minus 3 is equal to 0. So tan theta will be 4 plus or minus b square 16 plus 12 by 2. This will be 2 plus or minus, how much is that? 18, 28. So that will be 7. We got 2 answers. Why did we get 2 answers? And if you see, one is a positive answer, one is a negative answer. That is because you thought you have to throw it up, but Max is saying, boss, there is one more possibility. You can throw this down also, theta 2, and you can still go into the window. So we didn't realize this, but Max is telling you, boss, there are 2 answers. There are 2 ways you can throw this into the window. One, throw up and goes inside, or you can throw down and go inside. So that's why you're getting 2 roots. So this is theta 1 and theta 2. The negative angle is the one which is thrown down, and the positive angle is the one which is thrown up. Is that clear, everyone? So there are 2 ways you can throw this particle into the window with this given data. 2 plus or minus root 7. Any doubts on this? All clear with this? People are tired today. What happened? Too much projectile. Things are flying everywhere. Last one for the day. Particle is projected at g1 theta. We have gravity g. We also have a horizontal acceleration. So let's say there is a wind blowing here, and A is the acceleration due to wind. You're getting it? So now we also have a vertical gravity and horizontal acceleration. Both are there. So the wind is generating an acceleration in the horizontal direction A. Find h max. Find time of flight. Find range. Find the acceleration of the wind if particle comes back to the point of projection. The wind is blowing so hard, it goes and comes back to the same point of projection. Draw the trajectories for different values of A. Means for different values of A, how will the trajectory roughly kind of look like? Try draw trajectories for different values of A. Let's get the first one. B and C will come automatically. Again, the wind and all look scary. It is not. If you have remember what we have done, the derivation, it is manageable. Right, Arya. Get it. Hmax and time of flight are easy. You can add them, right? Right, Samik. Think. I'll give you a minute, then I'll tell you the first one. It's not a tough one. Right, Shreyansh. Think for a minute, then I'll show you something which you have done before. Then I think you'll get the answer immediately. Right, Utsa. Right, Samik. Yeah, fast is fine. Go back to the derivation of projectile. Do you guys remember here what did I write? Look at this page. Whenever you're going up and down, or whenever you're taking time of flight, which velocity is responsible for all of this? The vertical or the horizontal? The vertical. Agreed? Now, can you see in this formulas? Is there in this formula, any formula, is there any AX anywhere? When the motion happens up and down, the horizontal acceleration does not affect the problem, right? Is that making sense? How much you go up and down, why will that depend on the horizontal acceleration? That means in our problem here, the horizontal acceleration does not affect the motion in the vertical direction. Therefore, the Hmax and time of flight will remain same. U square sine square theta by 2g, time of flight is 2u sine theta by g. Bas, itna hi tha. You just put one argument and then you write the answers. So for the first one, the answers will be this. If you remember the general formula, Hmax is ui square by 2ay. There is no ax only in the formula. U square sine square theta by 2g. Time of flight is 2uy by ay. 2u sine theta by g. There. So basically the vertical motion is independent of horizontal acceleration. So whatever happens in the horizontal direction, that's not going to affect anything in the vertical direction. So these two will remain same. What about range? Sx is equal to ux t plus half ax t square. Now ax won't be 0. This was the reason I was writing every time like this. So the range will be ux will be u cos theta. This will be time of flight. This will be half. Remember, ax is minus a. Why minus? The wind is blowing to the left side. It's decelerating. If the wind is blowing to the right side, it will be accelerating. I'll write plus a. Time of flight square. Substitute here. This will be u square. Sine 2 theta by g. This will be a regular range. This will be a by 2. 4u square sine square theta by g square. You can leave it here. You can't simplify it further. This is your range. You can cancel that 4 and 2 also. You will get 2a. So if the wind is blowing, this will be the range. It's not a standard formula. Don't need to remember, but understand how we solved it. Have a look at this. All clear with the steps? Hmax, time of flight will remain same. That's it. Directly you can write that answer. The wind is just there to scare you. The range will get affected. Yeah, because the time, there's a horizontal acceleration now. All clear with this? What is the B part of the question? Find A if the particle comes back to the point of projection. If it comes back to the point of projection, then what is the range? 0. That means if I put this is equal to 0, I'll get a value. So for the B question, it comes back to point of projection. Therefore, range is 0. So if you equate this to 0, you will end up with u square sine 2 theta by g is equal to 2a u square sine square theta by g. That will be 2 sine theta cos theta. So if you solve this,
It's a G square.
G square, yeah, you end up with tan theta is equal to G by A. 2 sine theta cos theta, sine theta, 1 G will cancel, yeah. So if you project with an angle tan theta G by A, it will come back to the same point. But if I just ask you only the B question, right, this is too long to do this question. There's a much better way. But have a look at this. Yeah, A is G cot theta or tan theta G by A, same thing. Got it. All got till here? Now tell me, see. Generally, you know what people will think? People will think like this. This particle will go like this and come back like this. This will never happen. Whenever you're throwing up, this will happen maybe in real life because of wind resistance and all that stuff. But what we are doing here theoretically, whenever you're throwing a particle, you have only two possibilities, isn't it? If your acceleration and velocity are opposite, you'll go in a straight line. If acceleration and velocity are at an angle, you'll get a projectile motion, isn't it? You get only two trajectories in kinematics. Either you go in a straight line or you go in a projectile motion parabola. You can't get any weird paths like this. So the reason is this, what is happening here now? When you got range 0, this is what happened. This particle is projected with u and theta. The wind acceleration was A and the gravity was G. The resultant acceleration has become in this direction. This is your net acceleration. So A and G together are pushing opposite to the velocity. If that is theta, this is theta, then tan theta must be G by A. Are you getting this? The reason the particle is coming back to the point of projection is because the acceleration and the velocity has become opposite to each other. So this particle is going up and coming back on the same line. It travels on a straight line. So for the particle to come back, it must have been going in a straight line. The particle goes in a line and comes back to the initial point. Right? This is possible if velocity and the net acceleration are opposite to each other. Net acceleration. So A and G together will create an opposite acceleration.
So we could take a direct like resultant of A and G and use it like 1D
That's it.
motion.
Yeah, it's a 1D motion actually. It's going in a line. तो ये सब करने का जरूरत नहीं था. Range and all. If you just want angle, this will give you one step में answer. Right? So this kind of trajectories will never be possible. The particle will never go like this and come like this. These kind of paths are not possible. Either you go in a line or you go in a parabola. That's it. You have only two paths in kinematics. Clear with this? So this particle here goes in a line, comes back in a line. All clear with this? The last thing, the trajectories. So just listen to this. So basically what I taught you this last problem, right? This is the beginning of projectile on incline. So next class when we meet, we are going to do what happens if you throw these projectiles on an incline. So let's say you projected the particle with u and theta. And let's say A is 0. So if A is 0, the particle will go normally. Okay, we'll take this as a reference. If A is 0, there is no wind speed, it will go normally. Suppose if the wind is blowing forward, so if A is positive, means wind is blowing forward, the particle will go ahead. But did you notice something here? No matter how you throw, all the particles will have same H max. no matter whatever is the acceleration of the wind, just now we saw it is independent of acceleration of the wind. So if A is positive, this red line will touch this black line here and will fall down. So all the trajectories, right, no matter how you throw, they should touch the black line. Suppose if the wind is blowing little backward, it will touch the line here and will fall here. So this is the wind when A is negative. Wind is blowing backward. If the wind is blowing really hard with a super acceleration, then the path will look like this. It will still touch the black line and will go back like this. So here acceleration is much, much greater than negative, matlab highly negative. Suppose if you throw with a straight line like this, I'll show the black line only. There are too many lines. If you throw exactly with this thing, A is equal to G cot theta, that will be a straight line. You'll go touch the black line, then you'll come back again. You're getting it? Among all those trajectories, there'll be one straight line and there'll be remaining all will be parabolas. So this is the case, it goes in a straight line. This is how the trajectories will look, everyone. A0, normal parabola. Wind is blowing forward, you will go little more. Wind is blowing backward, you will go little less. If the wind is blowing too much on the backside, then it will go like this. If the wind blows with G cot theta, you'll go in a straight line and you come back. All clear with the possibilities?
So will it be a parabola for the highly negative part?
That is also parabola, it is just tilted. मतलब ऐसा सोचो ना, you just draw a parabola here, then you just keep tilting the parabola na, like this, you just keep tilting it. But you have to just make sure it is touching this line. You can keep tilting it however you want. Is that clear, everyone? So this itself is a question in the exam. Huh? They gave 3-4 trajectories, then asked you for the velocity and everything stuff. You can see from trajectories also. There. So that would be the last one for the day. I know we did some good ones, so you all got tired also so fast. So, but make sure to revise this, especially these questions, the variable gravity questions. This was a mains ka PYQ, right? This thing came in the mains exam. Right? This was an easy one, the energy part. So this variable acceleration questions, this one is a pretty good one. This would be a proper advanced question. This is also standard one. This is result, you should definitely remember the result. You won't have time to derive in the exam. Yeah, so make sure to go through this stuff. So next class, when we catch up, we'll continue from here. We are going to do something called projectile on incline. That means we are going to take now inclines here like this. And we are going to throw on them. So we'll be doing that part next. Mostly should be able to wrap up projectile in the next class. And once that is done, we'll start off with relative motion and then graphs. I think, yeah, this will go for another maybe 4-5 classes. Okay, with that, we'll wrap up for that day. Then if you have any doubt, anything, you can stay back or else you're free to leave. So do make sure to write the exam. There is an exam online till Thursday night. So any doubts, anything, you can stay back or else you're free.